All right, 10-7, areas of circles and sectors. Now, a couple of vocab words. I need you to write these down in your notes so you remember them. A sector of a circle is a region bounded by an arc and two radii. So as you can see here, we have an arc, all right, which is the part of the circle between these 2 points, and then we have two radii. So that red shaded region is a sector of that circle. Now your next one is segment of a circle. A segment of a circle is a region of a circle bounded by an arc and a segment joining its endpoints. So now we have this arc here, and as you can see, we've drawn a line connecting the endpoints of the arc. So that blue area now is what's called a segment of a circle. A sector is like a slice of pizza. A segment is like the crust of the pizza. All right? Because it's just part. A segment is part of a sector. An easy way to think of it, a segment is part of a line. So a segment is part of something. So a segment is part of a sector. Remember, a segment is the crust on the pizza, whereas a sector is a slice of pizza. Alright? Relate stuff to food, everybody remembers. Now, how do we find the area of a sector? Alright, let's figure out how to find the area of a sector, and then we'll go into area of a segment. Make sure you understand the difference between a sector and a segment. So, the area of a sector is simply area of a sector. If we call this arc here, let me erase the word arc. If we call this arc AB, and then here we have a radius, of course the radius is R. So, area of a sector is the measure of arc AB divided by 360 degrees. So that way we find out that's 360, that's a sixth. So that way we find the percent of the circle that the sector fills in. And then we're going to multiply that by the equation for a circle. Of course, everybody knows the equation of a circle is pi r squared. All right, this is formula for area of a circle. All right, area of a circle is pi r squared. So you figure out what percent of the entire circle is occupied by your sector by taking the measure of the arc and dividing it by 360. Then you take that, multiply it by pi r squared. All right, you multiply it by pi r squared. So let's go back to this problem here. Let me erase the words. I'm going to leave AB up there. All right. Say this circle had a radius of 15 centimeters, and this arc was 72 degrees. What would be the area of that sector? What would be the area of that sector? First of all, we need the measure of the arc. Well, the measure of the arc is 72 degrees. 72 divided by 360 times pi times your radius, which is 15, squared. All right. So 72 divided by 360. This is 0.2 times pi r squared. 15 squared is 225, so this is going to be times 225 pi. Now, we're going to leave our answer in terms of pi. For a lot of these answers, you're going to leave them in terms of pi, which basically means don't worry about pi. Don't try to convert it. Don't try to multiply it. Just bring it along for the ride. All right? Just bring it along for the ride. So 0.2 times 225 is 45 pi, and our units are centimeters squared. Remember, area is always units squared. Regardless of what you find the area of, it's always units squared. All right, so just to review this, measure of the arc divided by 360. So the measure of our arc is 72 degrees. We divide it by 360. Then you multiply by the area of a circle. The area of our circle is pi times our radius, which is 15 squared. All right, so just bring the pi down for the ride. 15 squared is 225. 72 divided by 360 is 0.2. 0.2 times 225 is 45. Keep bringing pi along for the ride, and then your units squared. So the area of that red shaded region is 45 pi centimeters squared. 45 pi centimeters squared. All right. Let's do another problem here. Let me erase this. Make sure you write that formula down in your notes too, guys. Right here. Make sure you write this down in your notes. Area of a sector, measure the arc divided by 360 times pi r squared. Make sure you have that written down. Alright, so here we have a circle. This angle is 75 degrees. The radius is 9 inches. So, how do we set this up to find the area of the sector? Find the area of the sector. Alright, well first we need to know our formula. Area equals the measure of the arc divided by 360 times pi r squared. Measure the arc. Well, we don't have a measure out here, but if you remember from the last video, we know that the measure of the arc and the measure of the central angle is the same. So that means the measure of our arc is 75 degrees. Divided by 360 times, remember, just bring pi along for the ride, r, which is 9 squared. So area equals 75 divided by 360, which I'm going to leave that in a fraction, which is 5 over 24. The reason I'm leaving this in a fraction is because it gives you a run-on decimal. Alright, times pi, 9 squared is 81. Alright, so now the area, I'm going to move back up here, is 5 times 81 over 24 pi. Now, we could reduce here because we can pull a 3 out of both of these. Alright, 24 divided by 3 is 8. So area equals 5, and we have an 8 down here because 3 will come out of here. Reduces to an 8. 3 will come out of here. Reduces to a 27. Alright, so 5 times 27 is 135 pi. Now, I would take 135 over 8 pi, or I would take that your area equals 16.9 pi inches squared. Alright, they both come out to be the same answer. Right? Even if you didn't reduce it, even if you just took this, the 5 times 81 divided by 24, even if you just took that and took it into a decimal, you'd get 16.9 as well. But remember, pi, when it says leave your answer in terms of pi, pi just kind of comes along for the ride. You don't actually do anything with it, but keep up with it. All right, you don't actually do anything with it, but keep up with it. So you just bring it down, bring it for the ride. Now, if it said round your answers to the nearest tenth, all you do is 16.9, hit the pi key on the calculator, hit enter, it'll do the conversion for you. All right, it'll do the conversion for you. All right, so this is pretty simple. Let's move on to finding the area of a segment. All right. So let me change this up. Now, what I'm going to do here, save some time. We know that the area of this sector, equals 16.9 pi inches squared. All right. So now find the area of the segment. To find the area of the segment, what we have to do, you see how this makes a triangle in here? All right. So the area of the segment equals the area of the whole sector, which we just found, that's why I'm keeping it, minus the area of that triangle. All right, so it's the area of the entire sector, which we just found, minus the area of the triangle inside. That's all it is. So, area of the segment, we have the sector, let's find the area of a triangle. Well, if you recall the formula the new formula for finding area of a triangle that we just went over, it comes in real handy here. You have 1/2 of one side times another side times the sine of the angle, but this angle has to be the angle between these two sides. All right? It has to be the angle between these two sides. Well, if you look up here, this is an isosceles triangle. How do we know? We know because these two sides of the triangle are radii, so we know that this is 9 inches as well. So to find the area of our triangle now, it's going to be really easy. All right? The area of the triangle, I'm just going to draw a triangle, is 1/2 of 9 times 9 times the sine of 75 degrees. Now, if you didn't have this angle, but you knew the arc was 75 degrees, you would use the arc length that is bounded between these two radii. All right, so you just punch this into your calculator. 1/2 times 9 times 9 times the sine of 75. So 1/2, 9 times 9 times the sine of 75. Making sure your calculator's in degree mode, you're going to get that the area of this triangle is 39.1 rounded to the nearest tenth. All right. So now we have the area of the triangle, 31.9 inches squared. Have the area of the triangle. We have the area of the sector, so we're just going to take the area of the sector and subtract the area of the triangle. Now, they can also ask you to leave this in terms of pi as well. That's actually the easiest way to leave your answer, because if they say, what is the area of the segment, leave your answer in terms of pi, it's simply got to be this. The area of the segment, SEG, equals 16.9 pi minus 39.1. And of course, this is all inches squared. That's it. If they say leave it in terms of pi, just go this minus this, write it down, leave it alone, and finished. All right? But if they don't say leave it in terms of pi, if they say round to the nearest tenth, then the area of your segment would simply be, type this in, 16.9, and hit that pi key on your calculator, and then just go minus 39.1, minus 39.1, hit enter. It'll take care of multiplying this by pi first, and then subtracting the 39.1, rounded to the nearest tenth, you're going to get 14.0 inches squared. Alright? So, now that we have a super easy way to find the area of this triangle, and the cool thing is, when they give you this circle, in order to do this, they got to give you the radius. Alright? They got to give you the radius of the circle. And if they don't, you can just find it backwards using the area of the sector. Okay, but the majority of the time, you'll get the area of this circle. All right? So if you get, not the area, I'm sorry, the radius of this circle. So if you get the radius of this circle, it's simply 1/2 times s. Well, when we're referring to this circle, it's 1/2 r times r times the sine of the central angle. All right? So that's what we did here. Our radius is 9. 1/2 9 times 9 times the sine of 75. That gives us the area of this triangle. We already did the math to find the area of the sector. You just simply subtract the sector. You subtract the triangle from the sector. All right, so 16.9 pi minus 3.1 or 14.0 inches squared. All right, it's not that difficult, especially with this new formula we just learned to take the area of a triangle. It's not really that difficult anymore. Because you're given r, you're given the angle between them. Why not just multiply all the stuff together and divide by 2? All right, let's do one more problem. Hopefully you wrote all these formulas down. If not, back the video up. Write them down. Because you're going to need them. All right, here we have a circle. All right, let me get a problem. All right, here we go. All right, I'm going to use this as one of the old-fashioned U-tries. I want you to find the area of the segment. Remember, a segment is part of a sector. It's like the pizza crust. So it's this red area. So find the area of the segment. Find the area of the segment. Pause the video, take a little bit, and find the area. All right, area of the segment. We know the area of the segment, SEG, equals the area of the sector minus the area of the triangle. First thing we need to do, find the area of the sector. So the area of the sector, SEC, is going to equal the measure of your arc. What's the measure of our arc? Well, I didn't write an angle measure anywhere. But, little box, what does that little box mean again? A right angle, good. So we know our 90, that's the measure of our angle, divided by 360, times pi, times your radius, which is 8, squared. Alright? So, simply do the math. 90 divided by 360, what is that? Well, that's 1/4. Alright, so we have 1/4. 8 times 8 is 64. And then pi feet squared. So we just, basically, it's just 64 divided by 4. So the area of our sector, which you should have gotten, is 16 pi feet squared, or as a decimal, rounded to the nearest decimal place, is going to be 50.3 feet squared. So our area of the sector that you should have gotten is 50.3 feet squared. So that's the area of our sector. So we're getting close. Area of the segment equals area of the sector. I'm just gonna round it all to the nearest decimal place. I mean to the nearest tenth place. All right. So there's that. Hopefully you got that. Now we need to find the area of the triangle. Remember, it's 1/2 your radius times times the sine of the angle in between. So this is 8 times 8 is 8 times 8 is 64 over 2 times the sine of 90. So 64 divided by 2 is 32 times the sine of 90. So this is 32. The sine of 90 is 1. So this is simply 32 feet squared. So we're going to subtract 32 feet squared. Alright, so 50.3 minus 32 leaves you with 18.3 feet squared. So that is the area of your sector. Alright, that is the area of your sector. Alright, so finding the area of this triangle is really, really simple with this new formula. Alright, it's just simply 1/2 your radius times the sine of the angle between them. Alright, your radius, remember your radius is 8 feet, so it's 1/2 times 8 times 8 times the sine of your angle. The sine of our angle is 90, so it's times the sine of 90. So 64, 8 times 8 is 64, divided by 2 is 32. The sine of our angle, the sine of 90 is 1, 32 times 1 is 32. So you do the 50.3 minus the 32 to get 18.3 feet squared. Alright, so this has been your 10-7 areas of circles and sectors. I know this video has been a bit long too, but hey, the material we're getting into is taking a little bit longer to explain. Alright, thanks for watching. Make sure you come to school tomorrow, ready to work some problems. See you tomorrow.